Hello everyone. Today we continue our discussion on addition and subtraction of vectors. So in the last class, I explained how we can use the parallelogram rule to get the resultant of two vectors. So today we are going to be using the head to tail rule or to tail to head rule. So that this is also a simple method that you can use to to get the resultant of two vectors. So what's the head to tail rule? The head to tail rule just in essence just means that if we are adding two vectors together, then take one of the vectors, take the tail of one of the vectors and attach it to the head of the other vectors and to the head of the other vector, and then draw a vector from its tail to the head that you just attached. So if you remember, I've already said in the previous video that we can move any vector that we have and it wouldn't change anything. So far we don't change its magnitude or its direction. So vectors can be moved around. So what does all this mean? Say we are still using this our example. Now we have vectors A and vectors B. We have vectors A and vectors B. Now I want to do what? I want to add these two vectors together. What can I do? They say that I should move the tail of one of the two vectors to the head of the other. Then I will complete a triangle. So any vector that completes the triangle is our what? Is our resultant vector. So let's do that. So now let's see. Let's do that now. Say I have vectors A and vectors B that I want to vector A and B now that I want to add together. What I can do now is what I could just shift vector A. This if you notice vectors A and B, their tail are touching each other. So I could shift the tail of vector A to the head of vector B and then complete a triangle. So let's do that. Let's duplicate for sorry. So let's do that. So sorry. So let's duplicate this first. So I could just shift this tail to this head, shift the tail to this head. So this one now I can remove it. I can shift the tail to the head, then we'll complete a what? I'll complete a triangle. Complete a triangle from this B tail to the head of C that I just moved now. So you can see that we are still getting the same thing as before. So we are still getting vector what? Vector C. Another way that I can do this is not necessary that we have to shift vector A. I can also shift vector B. So now I've gotten back to the where we started from. Now I can shift the tail of vector B to the head of vector A, and I'll still get the same thing. So let's do that now. I could as well shift the tail of vector B. Let's duplicate. Then I can just remove this and just shift this tail to the head of vector A. I will still end up getting the same vector. So in essence, this is just proving to us that vectors A and B, the addition of vectors A and B is what? Vector C in this case. Thank you very much. See you guys in the next